Bonjour. And then Marc Bruyere. I'm going to be presenting the works of different years and study some deployment in 2015 as well on the PK8, but moved to faucets recently and have an in production from 2017. But this is a new works on the config generation part and consideration of the cost to manage the internet exchange. Then what is internet exchange? You need to be at least 3 operators locally in the same city. And then you start to connect on the single switch and you start to peer through BGP and exchange traffic. That's the minimum definition of internet exchange. But the main functions provided here is layer 2 switching fabric. But you have a lot of different services, whereas proposed service, Looking Glass, root server, AS112, NTP server, DNS, many other management systems that's necessary to run your internet exchange. Then depending in the type of internet exchange and the size of it, but then you have different type of tasks and people and organizations, and with different type of cost associated with it. Then the administrative and commercials, if it's a commercial internet exchange, the engineering and technical parts, and you have also the cost for the hardware itself, for renting the racks and so on, fibers. Then I split into different type of domain actions. One is the one for member or customer. One I call member is for non-profit, and customer actually for commercial internet exchange. But this domains is to manage the connections of the members connecting to the switching fabric and services. And then there's a special task to be able to do so. And if we look into the different cost level associated with when you want to connect a new member to your internet exchange, and then the one we see was pretty high is when you have to do the provisioning and the setup and the validation of the connections. Different operators, they come with their own router and specification, and you have to ensure that they're not going to disturb the switching fabric and the service of the running internet exchange. Then you have to go through different VLAN quarantine and verification that they're not sending back traffic, configuring the root server, different informations to be able to have the new member to peer and exchange traffic with others. What we want to do is to reduce that cost at the minimum, because what is difficult is to also teach the new member if he's not aware of it. But the main things is to configure and maintain the internet exchange. That's what we want to do, is to very simplify and not get a lot of complexity for turning on new service. Then we have the same but more complex with the IXP domain actions. The internet exchange switching fabric itself and all the different services. When you have to add a new switch or new capacity on your internet exchange, you need to prepare it, and then there's a lot of different configs could be done and could be quite complex for small and medium internet exchange especially. Then the cost is even higher. Also, and along the process to turn on new switches or capacity on new internet exchange. And what we want to do is to lower as maximum that part. That's the goal. And why this cost is so high? Then the main reason is not only because of configuring, is the complexity of it. So many different protocols, and so everything is there, and you don't need them. You need to turn off and on again different functions to be able to get exactly what you want. And vendors with non-SDN are actually proposing different services for internet exchange. If you think of internet exchange those days, they use for scalability, they use VPLS. then you need to turn on an OSPF layer 3 transport network, configure your MPLS, and manage those things just for getting a layer 2 switching fabric. It was pretty insane. And some are even turning VXLAN with a lot of overhead for small packets, was not good for the members and for the traffic itself, and is way too complex. But the only solutions that Internet Exchange those days have. Then the way they turn on doing it is the specific language, low-level vendor-specific language that everybody knows, and then a simple typo on your config, and you may turn off your entire switching fabric and getting no services through the members. Then the complexity plus low-level management got problems, and you get higher costs. You need to get high-skills engineers and then maintain the different features, and you buy it. It costs as well also when you buy the features. And how to reduce the cost? Then we want to reduce the complexity, get a full control plane testing, and full zero-touch approach of it. The way we're going to do it is use the umbrella switching fabric. I will talk a little bit later about it. Then validation phase with Mininet, and then the IXP Manager is full stack zero-touch provisioning. I'm going to talk and present with a demo that IXP Manager, and MX Graph with the visual diagram I'm going to present. Then if we go back to the process for connecting a new member, then we want to do provisioning with IXP Manager. With web pages, you have to fill the different information of the member, and then we're gonna generate automatically the faucet config out of it, and we test the control plane with Mininet before deploying it. Then to change the switching fabric with the most costly and difficult ones, provisioning with IXP Manager as well. Then we do visual diagramming, and then that's the things we added to IXP Manager that I'm gonna show you later. And we generate the faucet config, we test it with Mininet, and then we can deploy. Then that's for the process, but for the proposed architecture for the control plane and monitoring, when you use the classical faucet and gauge with Grafana, but now we get MX Graph. And MX Graph is actually with Draw.io. Draw.io is Draw.io that we talked yesterday quite a lot. They have an open source core engine that's going to be used, but it's connecting directly to IXP Manager. Then IXP Manager is more than 10 years exist. IXP Manager is a full stack suite management system developed by INEX in Ireland. They run for their own Internet Exchange at the beginning, but it's a full open source project. It's 81 Internet Exchange using it on mostly a little bit more than 600 Internet Exchange. It's a growing number. In the past 2 months, increased more than 12 more, and then we get 81 those days. Everything in IXP Manager is based on best practice to run your Internet Exchange. You have the full zero-touch provisioning, but it does not include the configuration for your your switching fabric. Then you have to do you get your network engineers to configure the switches, because the provisioning is not taking care of this part. It does all the provisionings for the root server and the different services for the software part, but not for the hardware. Then they have all the different root server configuration generation, especially for advanced BGP policies. And is a good service for members and for the operator of the Internet Exchange. Then the MX Graph, as I mentioned, is an open source core engine that's coming from the community of Draw.io that we modified, and then we get to use the API from IXP Manager, that MX graph is actually pulling information from the IXP Manager. And then we can place, and I'm gonna do a small demo later, we can place the different switches that's been provisioned by the IXP Manager. And then we can generate, based on the shortest path, the source routing layer 2 encoding of Umbrella. And then we can do some mechanism for placing the failure and recovery. The Umbrella switching fabric is a work I've done during my thesis in from 2012 to 16, and is actually in production on Internet Exchange in Toulouse for some time. But it's scaled to even to thousands of hosts and could be multi-terabit as it is. And he introduced even the no open flow core switch. Then the core switch itself could be no open flow, and I'm going to present quickly just a slide about it. We use approach for source routing layer 2. We encode on the destination MAC address the path into the switching fabric, and we have no more broadcast because we are unicasting the broadcast packets for HARP and ICMP v6 and D. We know the destination. Why and how is because it limits the effect of broadcast on small CPUs used on the routers, and we can do that, and because we know from the beginning where the destination of the Internet Exchange, of the members of the Internet Exchange are. And then the HARP is for discovering the layer 2 and get the response, but we know in advance where they are. Then we program into the data plane the HARP functions. And the core umbrella itself was not the edge switches. The edge switches are managed directly by Fawcett. Then I programmed Tofino switch to do a very simple 3-step process that checks the very first byte of the destination MAC address, shift for 1 byte to the left and forward to the port from the information of the step 1. And this is just for forwarding the core very quickly and very efficiently, and introducing concept of no management at all on the core switch. Then no CLI, no interface, and so you just have to plug as it's been designed during the diagramming process. And I'll do a small demo to escape. There we go. I want to see my screen. Okay. I'm running a VM on my laptop where I get the IXP Manager running, and then we can find the IXP customer action. That's both sections, and the IXP admin actions. Then when we want to add a new customer, there's already a bunch of them already there. You just have to fill the different forms, and so then from there you're able to provide them the interface to your Internet Exchange and switches. This is the different actions, and everything is through those interfaces, and it also provisioning everything and generating the config for the root server, could be Quagga or Bird, and is all done through IXP Manager. But when you want to actually do the modification into the IXP domain, and you want to add a new switch into Internet Exchange, you just have to add a new switch. And then as it's a good point, as the Fawcett switches provided by vendors are actually also hybrid, they still run SNMP. Then it's pretty neat to use SNMP just for the provisioning and get the port index and information, then automatically fill the information without to manually insert it. Then we get already some different switches. Then with the different port and so. Then 3 switches are over there. Then you can see them. Then, for example, if I modify one and I call for Palo Alto PAX, Palo Alto Internet Exchange, I'll do that there, and I save the config. And then everything is done through this interface at the beginning. That's the first step. Then this is MX Graph. You may recognize a little bit Draw.io and so. This is fully in JavaScript. This is the editor part of the MX Graph open source project. We modified it. We added 2 functions, is to connect to IXP Manager. Then automatically just pulling those 3 boxes. And then the first one, okay. The first one is the one I just added and modified. Okay. Yeah, but as a diagram before, let me remove. I need to repull. It's better to use this one. Then this information is coming directly from IXP Manager. Then we have all the informations of the switch. The only thing is missing that we're still working on is DPID, that the XP Manager, we have not modified at all the XP Manager at that stage because we want to be compliant as a maximum with XP Manager as it is. And then new Internet Exchange can just connect it, whatever versions of XP Manager. But we need to manage to get that metadata and in a mixed graph, but there's still work in progress. Then we had this, and for example, we say 1, we apply this, we modify this, we had that new and DPID information to the block, and already prepare a link with the same information over there. Then we get the metadata for giving the switch 1, the port Ethernet 1 to switch 2, Ethernet 2, and the speed of the link. Then we just have to connect it. There we go. And then from there, we can generate the faucet config if you want to work. Oh. Yeah. Hold on. Ah, yeah. Because I changed the name of it. Okay. Okay. And here we go. We get the faucet umbrella config. It just respects the rules of pushing access lists based on the umbrella approach. Then it's fully generated by MX Graph automatically. Then from there, we have not developed yet the module for testing, but it will, based on the config from MX Graph on the topology, create a mininet topology equivalent with the host, and then push it and do a ping all and test the different scenario or turning off the links and so for verifying that everything is running as expected. But the good things is we can have different type of topology like this one that we can generate the config as well in the same way. And then that's not that one, is it? Yeah. With way more longer and so, but you just have to do the U diagramming and generate automatically this. And then you can also import from different beginning of what you already have maybe on draw.io. Then you can, for example, this one is a more complex one. Then on the same thing, you can generate the config and so on. And then yeah, you can also use that diagramming you've done, and you can save as and go. And it's fully compatible with Draw.io, and then you get the same information in through directly in Draw.io, just for your diagramming and all the things you want to do. But yeah, that's where we are at that stage. And then Faucet is already running at the Toulouse Internet Exchange for some time, but we're going to migrate everything with this diagramming approach, even if it's the two small internet exchange with about 10 operators each. But it's a triangle topology and pretty simple, but at least it will be running everything with IXP Manager and Emil Graph for testing and deployment and so. Then we still have to work on the failure detection recovery mechanism placement and the IXP Manager Faucet metadata that is missing. We had to insert manually on the MX graph, but we want to do that directly linked into another separated maybe database with pre-provisioning information for the OpenFlow part. Then finish to develop the testing modules itself. Then the conclusion is, I think we get, and that's something we need to evaluate during the deployments on the two internet exchange, but simplify the management and no need at all any more high skills requirement. Then full zero-touch automation and push on grain when everything will be tested. And the multi-vendor management-less core switch as well been introduced. And that's it. If you have questions. Yeah.
Is your custom functionality that you've added to image?
Yeah, it will be open source. Yeah, by now it's still a working process, but let's say December, as we're gonna deploy and so, will be more stable. But yeah, this is dedicated for the switching fabric of Umbrella, but this approach and the code itself could be used to maybe integrate. That's also the thought for Faucet community, that to use the functions as blocks and so, for using diagramming for programming your Faucet config.
So you described the before program, the source routing, was byte and shift, kind of mimicking, I guess, some kind of stack of nebulous.
Yeah.
So for that, that's not an open flow solution. So what parts of the network are open flow Faucet? What parts?
Yeah, then you can use open flows on the core, but all the edge switches are Faucet. Then where all the customers are connected is fully Faucet. Then the core switch is no customer member connectivity there. It's just for aggregation, and it's simple as possible.
And so I think I understood you, but your P4 devices, you meant to firmware there and that.
Yes. Yeah.
So the P4 devices, like set
Yeah. There's no config, there's no event tables, and everything. So I get the code running was
no config.
No event table on P4 because you can.
Like a two-level network, level core switch, and then
Well, you can have more core. You can have more core chained together if you want. Yeah, sure. but it will be transporting as a core with no edge connections. It will be transporting with the umbrella mechanism. And then you can have 2 6 op in the encoding matter we use, because it's 48 bits of a MAC address. And then it's 6 byte, but yeah, without entering into the umbrella part. But yeah, you can go to 6 op, or you can increase it if you want as well, just modifying the number of bits you want to match to even way more. Different mechanisms exist. And yeah. Any other questions? Oh, sorry.
Seeing Mark.
Here's up.
Seeing Mark Hanley's name in my source proposal, source routing is sort of all your problems, and that's sort of what you're doing with your fabric is all source routed. And so
Yes.
I guess the question is, is there any what's the advantage of doing this with an umbrella and P4 versus using or other forms of source routing that already might exist off the shelf?
Yeah, the benefit is the use case of Internet Exchange. You just want layer 2 only. And then because the layer 3 is fully managed by the IXP itself, the members, but just for transporting on the very layer 2, no overhead at all, is just dedicated to. Yeah, but
and I guess you're saying the advantage of not using MPLS. Is that the?
It's just MPLS, you have to configure it and so and so. It doesn't. Yeah, I mean it's just you don't need any config.
But
it
you
is.
do, you need to download it's the same thing, right?
Yeah, I mean for the core itself, yes, yeah.
So,
But it's way simpler. I mean, yeah.
you claim that having installing a P4 program having a step.
Or when it's already developed, yes, yeah, it's the case, yeah.
Okay. I'm not convinced of it.
Any other questions? Thank you.